All right, welcome back to my OS hacking and development environment. Today, I thought I would be implementing SIGCHLD, which is the signal that a process gets when one of his children dies. Um, and then you can use that to wait on your child so that the process can get destroyed. Because until you wait on a child, after it dies, it sticks around in the process table as a dead process. So um, I currently have like in Serenity right now. What happens is that I'll show you that let's start a terminal and then exit the terminal, and then we can see that we have this dead process here, a dead terminal, and a dead shell process. And obviously, we want those to go away. So we need a way to notify the launcher here that the child has died. And that's going to be through the SIGCHLD process, SIGCHLD signal. So let's have a look at that. And I figured, let's see where we start today. Let's just close everything. Okay. And how about we start looking at how I already send signals, because I have some signals. Is it send signal? Yeah. So I have a kill syscall, and I have TTY. The TTY can generate signals, like interrupt signal and stuff like that. But basically, yeah, so it's process, send signal, the signal and sender. Okay. So let's just go ahead and look at when a process dies, then we could do something like, let's see, auto parent. Let's get the parent process, and let's just turn off interrupts while we do this, because I know that from PID it's going to complain if I don't turn off interrupts. One day I'm going to make that thing not depend on turning off interrupts, but for now we have to do that. Let's call that parent process. All right. If we have a parent, we might not have a parent when we die, so kernel will take care of that elsewhere. But if we do have a parent, we want to tell the parent. We'll tell the parent that one of his children has died, and that I'm the guy sending it, I guess. I wonder what's the significance of telling them who sent it. Oh, maybe it's just oh, it looks like it's just for logging, actually. So that's cool, because I was thinking, like, we don't want to store the pointer to ourselves somewhere. Or, well, I was thinking that, like, since we're going away, we don't want to store the pointer, but actually we're not going away just yet. We're just becoming a dead process. It doesn't mean that we get cleaned up. Kind of the whole point of this is to enable cleanup. So so we were in die, right? So we're here, and now we're going to send a signal, SIGCHLD this. Okay. And then let's go ahead and in the GUI test launcher app, let's just listen for that signal and try to react a little bit if it comes in. That would be signal.h. And let's see, how did this go again? Let's just put that at the top here. Signal, SIGCHLD. Okay, and then let's see. And handle. Oops. We don't care. We know that it's SIGCHLD. And let's just go ahead and print that we got the signal. Okay. Oh, and we're gonna have to build everything actually. Let's see how this goes. Because if I recall correctly, the default behavior in Unix is that if you get a SIGCHLD, then if you don't have a handler for it, then the default behavior is just that you automatically wait on the child so that it dies peacefully. Let's see here. Yeah, we got SIGCHLD. Okay, that's cool. And so that part's probably good. And I feel like I read somewhere about SIGCHLD. Maybe it was here. Let's see. Zombies from the terminal. Well, I think we can do this and or actually let's leave it like that for now. And let's put this into a commit just so that we can have a commit just for this. Kernel. Process, and I should send. Okay, so that's pretty cool. And well, what is it? Automatic behavior. I'm just going to go to the internet and look that up. Let's see. What's this about? SIGCHLD that calls wait PID. But like, how do we know what PID to wait on? Because wait PID. Oh, I guess maybe we can wait PID -1. So I was wondering, like, how do we know what to wait on? But I guess I think I already implemented this. Yeah. So if the waitee or the thing that we're waiting on is -1, then we will just wait for any child. So waitee is -1. This looks vaguely incorrect though, because I guess this will actually this will just wait on any dead process, not just my children. So I'm just gonna put a little fixing here. This looks like it'll wait on any dead process, not just children. Okay. Let's see. And what did this thing say? -1. any child process whose process group ID is equal to the absolute value of PID. That's if it's less than -1. -1 is any child process. Okay. Okay. And I thought I'm just going to go ahead and say assert that weight t is greater than 0. Okay, so there are a few different ways to specify which process to wait for. So I'm just gonna have a fixed mean to implement those. But it looks like what we want is to just wait on any child process, right? That would be kind of a comfortable, easy way to just wait here, because just because we get the SIGCHLD doesn't mean that the child process is dead yet, so we gotta wait on it. Okay, so let's say wait PID -1. Don't care about the status. And should we say W no hang? Well, we shouldn't have to hang actually, because the thing is already dead, as evidenced by the signal. So there should be no need for W no hang, which would otherwise allow us to make a non-blocking call to the wait PID. So let's say assert RC is 0, because I think wait PID will just return 0 if it goes well. No, it doesn't. It returns to PID. Okay. Could have messed that up. What's the return thing? Right. Okay. So let's assert that it's greater than 0 then. And in fact, let's say that wait PID returned. Let's print it out. See what we get. Okay, and let's go ahead and fix that thing up to only wait on its own children, actually, because otherwise it's just going to get really confusing. Oh, wait, hold on, I'm stupid. It says for each child. Right. I was getting tripped up here. Okay. So it looks actually like for each child probably does what I want. Look to all the processes. If PPID is my PID. Yeah, okay, so it actually does. Okay, I was wrong about my past self. I had thought of this. Nice, so I'm gonna have to do that. Okay. Let's just build everything actually. Okay. So this would go through all the children, and then for any dead one, we will reap it and then gather the exit status. But I wonder what was the behavior if we wait on multiple. Do we just get the very first one? Yeah, I wonder. I mean, let's just see how this runs. We can think about improvements to it later. Okay, so let's start this guy and then exit him. And what did we get over here? Wait PID returned 8. Yeah, so wait PID returned 8. That's the terminal who died. And then let's have a look at process table, and that didn't go very well. We crashed. What the heck happened here? Oh goodness. I don't even know what happened. Okay, let's just start over. Okay, terminal, exit. That didn't go very well. Let's see. Got the SIGCHLD, then we wait. And then we get an unrecoverable phage fault and GUI test. And we're trying to run code at a null pointer. That doesn't look very good. Wonder how we ended up here. And then the Windows server gets all upset and gets into some different trouble. But like that's probably just let's not worry about the windowing server right now. I wonder what this null pointer deref is. It's not even so much a deref as it is a jump to null, which kind of suggests that there's something up with the signal handling code. I haven't been looking at that for a while. Let's just try that one more time and see if it's sort of a flaky situation, actually. So I open this guy, I close this guy, and then the process table is all wonky. And why is it terminate due to signal? What signal is that? Signal 17. I mean, I guess it's SIGCHLD, right? Yeah. So I do an exit in the oh. Right. Hold on. It's because the default behavior is when you get any signal, then you just kill yourself. That's not what we want. Let's see in yeah, maybe it's called dispatch one pending signal. Okay, and then this is here. Yeah, so here's if we don't have a handler for the signal, then we just kill ourselves. So this should probably be a little bit more mature. Let's see. There's some flags for this stuff, right? Blah, blah, blah. Let's just go ahead and say that if signal is SIGCHLD, then wait, what the heck? what's going on with this editor today. I was wondering what's the significance of returning false from this guy. Control Shift U, that's not it? Okay, whatever. Find usages. And if I can stop messing with it, dispatch signal is returned by this guy, who is called by scheduler. Let's see. If it returns false, then we don't unblock it. So then we wouldn't unblock. Yeah, I guess we don't need to unblock in this case. Let's just see what this looks like in practice. Now this guy is just sending the signal over and over. Right, that's not good either. What's the right thing to do here? I wonder. How do we find out about this? I guess we gotta hit the web again, huh? Default SIGCHLD. SIGCHLD. The default action for SIGCHLD is to ignore the signal. However, if you set the disposition to ignore, then it will also prevent the transformation of your children into zombies. Okay. So the default action should be to ignore. So let's go ahead and say that, I guess the issue here is that we don't have a handler, so we don't actually clear the signal thingy. So I guess we should always clear the signal thingy. I mean, we should always clear this as a pending signal because we don't have a handler. We're going to do some action. Whatever that action is, we've effectively taken care of the signal, right? So we don't need to go here again in the next iteration of the scheduler. So let's go ahead and clear that up there. And we'll test this out one more time. Yes. Okay, now the dead processes are gone, and that's very cool. So I guess it does feel a little bit hacky, right? That if handler is null, then we special case the SIGCHLD. So what the heck is SIGIGN anyway? I feel like it's like -1 or something like that. It's 1. Maybe. Like a lot of this, kernel hacking is like that. The way that I do it is that I just look at man pages. For like Linux and FreeBSD and stuff like that, and try to sort of work based on the documentation because I don't want to cheat by looking at other kernels. If I can avoid it, then I try to absolutely stay away from that because I feel like I wouldn't learn nearly as much if I didn't try to work this stuff out myself. So let's see, ignore, right? Ignore. So if it's sigign, then we will ignore the signal. Right. If it's null, then we should have a different scenario for here. Let's say next signal is handled, and then we don't need to do that again. And then let's see. So another ladder. Oh, wait, back up. It's right here. Look at that. If it is null, then we terminate. Right, but if it's ignored, then we would get here. So yeah, this is actually exactly what I wanted to do. So the only problem then remaining is that it's not sig ignored by default. So how do we set that up? Let's see. Maybe in the process creation, signal, and what the heck is that thing called? I have some, is it sig action? Handler or sig action? Signal action data, right. So the signal action data for each of the signals. Okay. Then when we create a process, let's go ahead and say, where is that? Wait, hold on. What am I even looking for? Right, this is process creation. And surely we do the signal stuff here somewhere. Am I just blind? We mem set it into exec and fork. We do it in exec. Wait. I see, the reset to the default. Well, let's start with adding a helper function called like reset default signal. Okay, set default signal dispositions. I think that's fine. And we can also do that in process. Because I feel like when we're in fork, then we're copying it over, right? We copy them over, entering exec. We set them to default, and yeah. So let's in the process constructor, let's go ahead and set default signal dispositions. That's fine. And let's just add that thingy. And put him somewhere. Where's a good place for this? Maybe next to, why not next to SIG action? Yeah, good enough for me. Okay, and then that can do memset and signal action data. What am I doing? Okay, and then signal action data for SIGCHLD can be SIGIgnore. Oh, right. Handler or SIG action. What am I forgetting? No? All right. Please accept my offering. There we go. Okay. I wonder if there's a list of these default signal actions somewhere. C-man signal. Is there a list? Older standards. Okay, well, let's go with this list and just trust it. Let's see, SIGCHLD should be ignored. Okay, we can worry about the rest of these later. Fix me. Set up all actions. Signal inspiration. Oh, not inspiration. Just see signal 7. Because it's not inspiration in there. It's like a cheat sheet. Okay. That's good. Let's run this puppy. All right, and is this going to do what I want it to? Okay, I don't know what that fluke null pointer crash was earlier. I'm just going to chalk that up to random instabilities of homemade operating systems, and hopefully run into it again eventually. But this seems to be working out nicely, and we don't see any dead processes. I'll maybe take this time to type into the terminal, and nothing happens. And okay, so what went wrong here? Let's have a look. This shell is in state signal. What does that mean? Oh, wait, what the heck does it mean that it's in state signal? That was weird. It was process number 5. Let's see, unblock due to signal. That was me pressing the, I was pressed Control C. Okay. Man, it's a little hard to follow here. Let's see, what the heck does it even mean, blocked signal? It's unmask pending signals. Oh, so when we are handling a signal that we ignore, okay, so I see here that this is part of my implementation of read and write, that if you are in a blocking read or write syscall, then if you get a signal while you're blocked, then we may need to unblock you and return early from read or write. Like for instance, if you are like blocking on a read and then you press Control-C, you want that process to wake up, return an error from the read syscall, and just wake up and be able to react, right? And you know, maybe someday I would want to be able to automatically resume reading and writing after a signal happens or an interruption happens, but I don't have that right now. But basically, we are in the state blocked signal because we have a signal to deal with. So so we're here, unblock right, and then we're going to go into, where do we go? Blocked signal, schedule, yield. And then we are blocked. And then nothing is going to unblock me. Nothing is going to unblock me. Or is someone going to unblock me? Blocked signal. What the heck is the point of blocked signal? No one is going to unblock you. Well, so hold on. I guess that previously blocked signal, before I started changing all this around now, previously if you would be in state blocked signal, the scheduler would eventually get here. We would do like dispatch any pending signals. Here we look through any process that's not dead and see if it has any unmasked pending signals. And in this case, we know that it does because we only set the state to blocked signal when there are some unmasked pending signals. So we are here, and we're going to try to dispatch that pending signal that we know exists. But now, what ends up happening is that we just ignore the signal, and we never unblock the process. So that's the part where I was wrong, and I think we do need to unblock the process. This is confusing API here, so let's go ahead and make this API better so that it's not so confusing. Scheduler action. Let's say unblock process, or no, let's see, should unblock process. Yes, no, let's do it like this. Enum class, and let's say okay, and then in this code we can say if dispatch one pending signal is no. Okay, And then here we say that in the case we're killing the process, we don't want to unblock it. But if we're ignoring, then we want to unblock the process. And if we are going to tell the process we're going to send it down into some signal handler, then we definitely want to unblock it. Okay. God, forgot about this code. This is some hairy stuff. Doing a little bit of manual assembly here, machine instructions. Anyways, okay, so let's go ahead and try this. Okay. So now we want to be able to run PS and then not be blocked. Yeah. And we want to be able to exit and then run PS here and see no dead processes. We're not blocked. Everything's good. Actually, I could be using top too. I don't have to use PS. Look at it go. All right, and then let's make a new terminal. And let's create a new shell. Exit that shell. It disappears from the process list. Make a lot of new shells. And as we exit them, they all disappear one by one. Nothing bad happens. And it's looking quite good. Okay, well, I think that is working quite nicely now. So let's do a little bit of a patch review. Let's see, git diff. Okay. So we set up the default signal dispositions when we create a new process, and also when we exec. So new process and exec, we set default signal dispositions. That's good. And we made a new enum for whether we should unblock the process or not, because it's a lot less confusing. And we always mark signals as handled in dispatch signal. And here we were just adding a little bit of fix me and an insertion in wait PID, so that eventually when I come across it again, then I can go and implement those different modes. Oh yeah, this is the guy that was setting up SIGCHLD to default to ignore. That's good. Here's set enum, blah blah blah. And we're using that enum, and then in the GUI test app, then we do a wait PID for -1. And you know, I'm sure that there are more improvements to be made here, obviously, but like I think that I'm happy with this for now. So I'm going to go ahead and commit this. Say, okay, let's say kernel ignore SIGCHLD by default. What's the other thing? Is there really anything else that's really relevant? I mean, that's really the big problem. Also added enum for the rather confusing return value from dispatch signal. Okay, use an enum. I need to go through the signals and set them up with the appropriate default dispositions too. I will go through. Okay. Okie dokie dokie. Well, I think that's cool. Let's go ahead and push that to the interworld. And yeah, so let's see. So what did we really do today is that I added the SIGCHLD signal, so that's automatically sent from a child process to a parent when the child dies. And then I hooked it up so that the GUI test launcher app listens for SIGCHLD and reacts by doing a wait PID, which cleans up the child process that dies. And then I also made sure to have the default behavior for any process that doesn't actually set up a handler for a SIGCHLD explicitly to just ignore the signal. Yeah, so that's like a couple of small steps on the path to a better and more complete Unix operating system. I think that concludes today's video, so I hope you saw something interesting here, and if you made it this far, then I thank you for watching, and I'll see you next time.